Hello! So, I'm hot on the heels of the last video, which is about host objects, and I don't know when I'm going to have time to film more of this video, so I thought I would just try to do as much as I can today. So basically, today, or on this video, I'd like to talk about the jsCallInvoker, which is a very important part when doing async code. So, I don't know if I'm going to be able to show you everything, including starting threads and so on. But I will talk a little bit about the jsCallInvoker and also about pointers. I think that would be useful at this point. So I'm just going to pick up where I left on the previous video, which was about host objects. If you haven't seen it, you should go see it now, because otherwise this won't make that much sense. And on the last video, here I had the smart host object where I basically got rid a little bit, commented some code out because we weren't ready to take a look. And it was basically this weak pointer to a React call invoker, which I just called the weak JS call invoker. So for now, all I'm going to do is I'm going to restore. Let me just take one more look into the code that I had before. I am going to restore what I had in there regarding the binding to the jsCallInvoker, and then we can talk about it for a little bit. Give me just 1 second. I need to take a look into the code. Okay, here it is. So I have my this is the deconstructor. I don't want that. And basically I just put the stuff in here. Okay, good. So let's go back all the way to the main binding and where the bindings are installed for the package. And here you can see when I'm installing the package, I'm getting a reference to the runtime, to the JSI runtime, to the JavaScript runtime. And I'm also getting this call invoker, right? So I get it from the bridge, jsCallInvoker. So let's talk a little bit about JavaScript and the JavaScript engine and how does that work and how does that interact with C++. So your code or the machine is running the native code, right? It just runs the code, and the JavaScript virtual machine is kind of this subsystem inside of this native code, right? It kind of has its own memory, it has its own stack, its own heap, and mostly lives in kind of this isolated mode where you cannot directly interact with the memory of the encompassing process. So in the perfect world, or in the easy world, let's say, where everything is synchronized, you don't have that much of a problem between executing some piece of native code and executing some piece of JavaScript code, right? Because you execute something on the native side and then you pass it to JavaScript. And the state is more or less synchronized. But what happens if you have some async operation, right? So let's say this is the JavaScript world. Here you have some operation, gets fired, and it goes all the way to the native side. But here you would start the async thread, right? This will change over time. You don't know when it's going to execute. And in the meantime, your JavaScript machine still has to run, right? Because the JavaScript machine is single-threaded. So it will still need to update your UI. It still needs to do all the ticking. It still needs to execute whatever async callback you have in there. So this machine will start doing things. And the problem is, once the native thread is ready again to send back the information to the JavaScript side, the state of this machine, the state of the memory of the virtual machine might have changed, right? So you cannot guarantee that you might be reading the same piece of memory, or you might be writing to the same memory stack or the same memory frame as when your when your function was fired. And this is the problem, right? This is where you might get some crashes. So the idea or the mechanism that you need a mechanism to synchronize between these two worlds. And basically this is what the jsCallInvoker is. It allows you from the native side, when you do some thread work, to safely interact again with your JavaScript virtual machine, with the state of the JavaScript context in a safe manner. So this is basically what we're trying to capture in the smart host object. We got a hold of this jsCallInvoker object, and then we need to pass it in the smart host object so that we can use it later. So I'm not going to talk right now about the share pointer or anything. Again, this is just kind of a way of keeping objects alive. But what's important to realize is this: why are we saving the jsCallInvoker and how are we supposed to use it afterwards? So now that I have restored the reference or my property here on my smart host object, when I initialize it, I need to pass it somehow. So here you can see on my iOS code, I get a hold of it and I'm already calling my install function with this CallInvoker object, which means here on my function definition, I already have a shared pointer to the CallInvoker. So basically when I'm creating my host object here, I create a shared pointer. I can just pass my I don't know what's this called, just CallInvoker. Let's see what happens there. So it's going to fail. Most explicitly initialize. Give me 1 second. Let me just check if I'm doing this the right way. I am missing something, definitely. I am just not really sure what am I missing. So I initialized base class, which does not have a default constructor. Okay, I think I know what the problem is. 1 second. Is it? No. That looks fine to me. So I have the native storage. I have this one. Oh, here I am missing the same reference, so it should be an std shared pointer, which is a React call. What am I doing? Call invoker. So here I'm just going to do namespace React Facebook React, and I have my jsCallInvoker. Okay, let's see if that works. And of course you're not matching. Namespace React Facebook React, and you take an std shared pointer of the class sorry, what was this? React CallInvoker jsCallInvoker. This needs to be, this should be fine. Maybe this needs to be a parameter. Give me 1 second. A pass by reference by no, it's a shared pointer. That looks fine to me. Must explicitly initialize, which does not have a default constructor. Okay, 1 second. Let me take a look what's in here. Oh, so sorry. This is just C++ semantics, which I am not super familiar with. So now it should work. Okay, good. It compiles. Great. So basically this is just inheritance, right? C++ inheritance. But now basically our constructor for the native storage takes an instance of the call invoker and we pass it to our smart host object, which means it's inside of this instance. So let me show you, what can I show you next? Let's try to do some async work. I don't know how far we're going to get, but at least I can show you the principle of it. So I'm going to talk about this thread pool class. And basically, I could do this without a thread pool. But you need to know that there is some limitation, especially on mobile devices. Not all the mobile devices support or have multiple cores. And basically what happens if you don't have multiple cores and you try to spawn a thread, you're actually going to make your application slower. That also happens if you spawn too many threads, more than the hardware supports. You're also going to make your application slower because your processor has to switch context, thread context, right? Every thread has its own chunk of memory and has to load different types of variables or information into the processor. So you really need to strike a balance in here between how many threads you have and what your hardware is capable to get the best performance out of it. So basically the thread pool is just an abstraction that kind of allows you to define the right amount of threads and also helps you coordinate work a little bit. I mean, you dispatch a task and you don't want to manually check every single time if you are using the correct amount of threads, but basically you just want to take whatever is available, and if not, you maybe want to just pause for a little bit. And this thread pool implementation is not something I came up with. I just picked it up from somewhere. But basically here, for example, you have number of threads, and this is a function of the C++ standard library. You have std thread hardware concurrency, which basically tells you how many concurrent threads is your hardware supposed to support. And then basically on that, you just create a thread pool with a fixed size, with a fixed amount of threads. And as you go scheduling work, you just take whatever threads available, you give it the task, and whenever the task is done, it returns to the thread pool and awaits for more job, right? So not going to go into the code. This is just, you can find a bunch of different implementations online. This is regular C++. So basically I'm just going to use this, and I'm going to go back here into this native storage class, and give me 1 second. Let me take a look into some threaded code that I might have in here. Task, okay. Let's just take this for example. So I am just going to create a new function. Let's just call this, I'm going to field push back. I'm going to build a new pair, async bar. I'm going to use my macro once again to easily create a host function. And here is the fun part. For now, let's assume it's fun. So basically, I'm just declaring a lambda function. And here, I'm just going to capture, I'm not going to go over again lambda functions, right? But I'm just going to capture the runtime, which is basically what I need in order to access or to read some JSI value, for example. But again, here you need to be really careful. You cannot really write, or you might even read at some point while your JavaScript is running, and the data that you might read at a later point might have changed. So again, you kind of need to think that your async work, your threaded work, is a fairly dangerous task that you're trying to do. But basically for now, I'm just going to capture the runtime, which will allow me to create JavaScript objects and whatnot. I would still need to be careful about what I'm doing, but for now it's fine. And here, let's say I will do some expensive computation, blah, 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 right? This whatever you need to do on the C++ thread. And then I'm just going to say, the result of my calculation is 42. So here, now again, we need to return this data back into the JavaScript side of things. And I'm not really sure how can I show you this easily. Let me just search for a piece of code that might not be too complex, because I don't want to get into the more complex stuff right now. Okay, let's do this. This is all complex, I'm sorry, but you're gonna have to. Let's do it. It's better now than ever. Okay, so first thing that I'm going to do, I'm going to reach from the runtime the global object. I'm going to get one of the properties as a function, and I'm going to use that function right from the C++ world, right? I'm basically going to call a JavaScript function from C++, and I'm just going to take the result, I'm gonna manipulate it, and then just return it again to JavaScript. And the one that I'm interested in is the promise property, right? So basically, from C++, I'm kind of Frankensteining my way into the JavaScript world, and I just got the promise constructor. This is what it is. This is a JSI or a JavaScript function, and this is basically the promise constructor. Now, I am going to do the following. I am going to call this function as a constructor, right? So basically, all that I'm doing here is I'm doing something like promise, new promise, so far. So the constructor of a promise takes a function that takes two parameters, the resolve and the reject function. And I am just going to do that by I need to create a host function, right? So I am just creating a host function, which is the executor, right? So let's imagine this is the part that this entire thing represents. I don't need anything of this except for my jsCallInvoker. And here you can see this is just a normal host function, blah, 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 where I am making a shared pointer out of the argument in position 0 and the argument in position 1, right? So basically this is the resolve and this is the reject. Resolve, reject. Nice. So then what I need to do is I have all this stuff. My function still needs to return an undefined value. Hopefully that will be enough. And finally, I'm just going to change this and I'm going to return my promise. So let me just move this just to check if I don't have any error. Can you build? Yes. Okay, that builds. So basically I have now created a function that returns a promise. And this is the inner side or the inner part of my function. And what I can basically do in here is just put my threaded code, and I can just say, give me 1 second, let me check if this is correct. I have my task, it's blah blah blah. Okay, good. So my threaded code is fine, and here instead of invoker I'm going to use the jsCallInvoker, which again is part of the smart host object, right? It's part of the constructor, so I know it's in there. And this is going to run on the thread. I'm going to calculate something, and well, this is very complex because this is from blah 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 blah. I need my response, and I need my response, and sure, let's try to see. Okay, I also need in here my jsCallInvoker. What do you have to say? Okay, so this should be my runtime. This should be my runtime as well. Here I need std. So I'm sorry, I took this from a different repository, so I just need to adjust all this code. Let me just comment this one for now. And my pool. Let me just check 1 second. The pool, I have it in here where I just basically, where are you pool? Where I create a shared thread pool. Let's see if this works. Okay. I also need to capture then my resolve and runtime cannot be implicitly captured because runtime resolve and to include thread pool implementation, and I also I also need to capture my pool in here, my thread pool. Okay, looks like it compiles finally. Okay, so you can see this is why I didn't want to touch it, because there's a lot of capture semantics involved in all this operation, which is not really important, right? Like, yes, it's kind of hard to understand because you need to make sure that everything you need is passed and is captured within the lambdas, but it doesn't really bring you anything, right? As long as you get it right at some point, it's just going to work. What is important is kind of the entire logic behind it. So this function, the async bar, is going to create a promise object which gets immediately returned, but internally you have a resolve function, or you have the function that's going to do the async work for you. Inside of it you start some threaded work, and when you're done you're supposed to go into the jsCallInvoker and basically call this invoke async method, which will safely allow you to interact with the runtime, with the JavaScript runtime, right? So then you can create stuff, you can return it without interrupting your JavaScript in the middle of an operation where it's writing or reading something and creating a hard crash. So I'm not 100% sure if this is going to work. We can give it a try and see what happens. So I'm just going to go again into my app.tsx file. Let me just check that this is still in here. Native storage, okay, this is still in here. And I am just going to do async bar. So again, this will create a promise, which means I should be able to do something like this. And I'm going to say async result res. And it crashes. Let's try to see if I can easily debug this. It's a function, it's an object, so probably current string as object. Okay, so runtime promise. As object. Resolve pool. Yeah, this is what I meant. It's kind of hard to work at the same time from the JavaScript side of things and at the same time think in C++. To be honest, I'm not 100% sure why is this complaining, because I always had a lot of issues with this kind of code. Give me 1 second, let me try to figure this out. So maybe I don't need to pass this per reference. Okay, that works. So yeah, the capture semantics and pointers and pass by reference or by value, it's always complex. I cannot really tell you an easy way to fix this. You just kind of have to try it and understand the semantics of each function that you're trying to interact with. So basically, here now you can see the order of my messages kind of changes, right? Because I have threaded the work. So before the number would come first, but now since it's async, it's going to be called after a bunch of work has finished. And here you can see 42. Just to make sure, let's just change this to something different. Okay, 120, so it works. I just realized why it works, because I made a shared pointer and I don't need to pass a shared pointer by reference. I can just pass it, and this makes sure that it doesn't get deallocated. Okay, anyways, we can talk about pointers afterwards, and weak pointers and so on and so forth. So basically, that's the idea of the jsCallInvoker, right? Interacting safely from async C++ code to the JavaScript virtual machine. I mentioned before that the smart host object could actually take care of this. I am not going to do this implementation because it's even harder to understand, but you can see more or less where this is going, right? You can make the smart host object actually hold the reference to the threading code, or actually just have a worker thread or something like that. And instead of you having to declare your implementation on every single method that needs this kind of threaded work, you can just make that an abstraction, a general abstraction, and every object that inherits from the smart host object can just directly or easily dispatch async code. It's relatively easily, because you still need to have some access to the runtime. You need to create a resolve or reject. This is if you use promises. You can also use the callback type of async work, where instead of returning a promise object, you just take a callback as a function that makes it a little bit easier on this side, and then on the JavaScript side of things, you can just wrap that into a promise. I mean, performance-wise, you might lose a little bit, but it's negligible unless you're doing thousands of operations at the same time. Okay, good. Before it goes even further, this was the jsCallInvoker. I think afterwards I will like to talk about the C++ side a little bit, which is C++ or the weak pointers, shared pointers, unique pointers, blah 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 blah. And yeah, there's a lot of more topics to cover, but I think this is a good base to start. Take care. It would be great if you guys can leave likes, subscribe, follow me on Twitter as well. So this really helps me not to only produce more videos, but to actually get some work and continue to explore the JSI and share my knowledge. But take care and see you next time.